continuing on with the discussion on lines, 9.3 is specifically looking at the concept of slope, or in other words, the steepness of the line. Does it rise or fall, and how steep is it? So say something like thinking about the slope, thinking about the steepness of the line. Graph the line through the points, find and interpret the slope of the line. Okay, so let me start by plotting the points. So I might need more room here. Let's see, what do we have? 7, 3. That's here. Okay, 0, negative 11. That's here. Okay, so when we're looking at the slope, we typically use the letter M, variable M for slope. So the steepness, one way to think about that is the rise over the run. That'd be the change in Y. So how much is the line, how much do we go up or down for each horizontal change, each change in X? So if you look at these 2 points, so from the point on the left here to the point on the right, what is the change in Y here? So as I go from point number 1 here to point number 2 here, let's see, I've gone up by, 11 plus 3. So 14. And the run, the change in X, that'd be from 0 to 7. So the run is 7. So the slope is the rise over the run. So we can reduce that to 2 over 1. Okay, so find the slope. So how do we interpret that? So the number on top, that's the Y, the rise. So we could say the Y increases by 2 for every 1 unit the X increases. That would be the interpretation. So if you look at the graph, let's see if that's true. So if we start down here, for every 1 unit X increases, the Y increases by 2. Look at that. So you can see that slope is 2 over 1. Looks like we did that correctly. Number 2. So here we have the intercepts. The x-intercept, negative 5, 0. The y-intercept, 0, 3. setting up to find my slope. Set up the rise over the run. So the rise, the change in y. Okay, so that'd be up 3. The run is the change in x here. 5, positive 5. Okay, so there's my slope. So how would I interpret that? The number on the top is the rise, the change in y. So the y increases by 3 for every 5 units x increases. Okay, so you could continue this line. Let's see, so I'd say the y, so starting say at this point, the y increases by 1, 2, 3 for every 1, 2, 3, 4, 5 units the x increases. So you can see that'd be the next point on that line there. Okay, so 4, negative 3. Oh, this is going to be a special one. Negative 2, negative 3. So remember this one, this is a horizontal line, right? So do you remember for a horizontal line, I can write the equation y equals negative 3. Because no matter where I am on that line, the y is always equal to negative 3 no matter what the x is. So you can still list the slope. So let's see. Looking between these 2 points, how much does the y change? It changes by 0. Like the rise is 0. How much does the x change? It increases by 6. 0 divided by 6 is 0. So my interpretation there would be the y increases by 0 no matter how much the x changes. So I'm always stuck there on that horizontal line. Negative 1, negative 2. And here's the other special one. So that line, remember that was a special line called a vertical line. And the equation of that line would be x equals negative 1, because no matter where I am on that line, no matter what the y is, the x is always stuck at negative 1. So again, I'm interested in the slope, but look at these 2 points. The rise would be 6, but how much does the x change? It changes by 0. I can't divide by 0. So I would actually say that slope is undefined. Let's see, 2 lines both pass through 3, 0. One has a slope of 2/3. Let me start with that one. So starting at 3, 0 here, my first line, let's do it this way. Has a slope of 2/3. Okay, so remember what that means. That's the rise over the run. So that means my y increases by 2. So starting here, my y increases by 2. How to do this? My y increases by 2. Let's see. My x increases by 3. So here's the next point on that line. So let's see, starting at 3, I've gone right 3, that'd be 6, 2. Okay, could keep going. So let's see, my rise is 2, my run is 3. Here's the next point. So starting at 6, I've gone right 3, I've gone up 2. There's my line number 1 then. Okay, what about line number 2? So line number 2 has a slope -3/2. Okay, so the rise is -3. So again, we're starting at 3, 0. So that means the y falls by 3. So let me move this. So the y falls by 3, -3, for every 2 units increase in x. So that'd be what, 5, comma, -3? Okay, so then again I can go, move that again. The y falls by 3 for every 2 unit increase in x. There's another point. Okay, let me connect those points with my line. And so there's line number 2. So these lines are kind of special. So if you look at the slopes here, This is something that we'll get to later, or maybe actually be in the next algebra class, but you'll see this again if you take more math. So look, see how this slope 2/3, it's the negative reciprocal of the other slope. So the fractions are the same except flipped, and one is negative of the other. So actually in this case, I can tell you that the lines meet at a right angle here. You see how that's a 90-degree angle? Because the slopes are negative reciprocals. So we would actually say these are perpendicular lines. That means they meet at a right angle. Okay, so that wasn't really part of the question, but that's an interesting fact. Two lines both have a slope of -1. One passes through 0, -3. I don't know, should I start with that then? 0, -3. It's going to be too light, I think. There's 0, -3. Let's see, what else do I know? The slope is -1. Okay, so remember what that meant. That means if the slope is -1, that's -1 over 1, right? Okay, so starting at that point, let's see, I fall by 1 for every 1 unit increase in x. Fall by 1 for every 1 unit increase in x. Fall by 1 for every 1 unit increase in x. There's line number 1. Okie dokie. What's the other line? The information here. The other through 2, -1. Now line 2 has the same slope, right? It says both have a slope of -1. So again, down by 1 for every 1 unit increase. Down by 1 for every 1 unit increase. So there's line number 2. So these two lines are actually also special because they have the same slope. We call these guys parallel lines. You see how they go on, but they never intersect? They have the same slope, but they never cross, never intersect each other. Here's a little application problem. If a house that's 1,400 square feet costs 180,000, one that's 2,000 square feet costs 210,000. Find and interpret the slope of the line joining the points. So here we're looking at the y as being the cost. And the x as being the change in square feet. So my yellow point there is 1,400, 180,000. My blue point is 2,000, 210,000. Okay, so comparing these two, what is the change in cost? Well, that'd be the 210,000 minus the 18,000. The change in square footage would be the 2,000 minus the 1,400. Okay, so this is 180. That's why those commas are a good idea, huh? Okay, 210,000 minus 180,000 is 30,000. $2,000 minus 1,400 is 600. So let's see, I can cancel 2 zeros. 300 divided by 6 is 50. Okay, so what are the units on the top? So that's change in cost. So that's in dollars per square foot. Okay, so let's see. What can we conclude? That in this price range, on average, the cost of the home increases by $50 per square foot.